Hello viewers, thank you for joining me in this lesson. In this lesson, we are going to look at how to find the distance between 2 points. So when 2 points are given, how do we find their distance? Let's consider a point A. We also have another point B. So we want to find the distance between the point A to B. Alright, which can be expressed as this, as with A, B. Now you can also think of finding the distance between your house and your school, between your home and the nearest shopping mall. You can also want to find the distance between 2 cities. Okay, so let's see how we can derive an expression that will help us to find the distance AB by using the coordinate plane. Now, on this coordinate plane, we have the x-axis and the y-axis. On the x-axis, we have the first point called x1 and the second point x2. On the y-axis, we also have the point y1 and the second point y2. Now, if I have here a point, this is call it A, and this will be the coordinate to be x1 and y1. Now we also have another point here, and let's call this C. Okay, and this we are going to have another point C2, and this point here we will call it B, and this will give us the x2 and y2. Okay, so from here we can join these 2 points from A to C, and we also join the points from C to B. So we want to find what would be the distance from A to B, because we already know the distance between 2 points. If this is going to give us the distance B minus that of A. Okay, so if we were to have here to be 10 units and here was 5, to find the distance between A and B, this is going to give us 10 minus 5, and this would be equals to 5. So we can say that the distance between A and B is 5 units. Alright, okay, now in this case we don't know the distance AB, and that is what we want to see how we can obtain the distance AB. So here we can put it to be AB, and finding AB by observation, we have a right angle triangle here, A, B, and C, and we can use the Pythagorean theorem to obtain the dimension AB. From the Pythagorean theory, we know that the dimension AB square will be equals to that of AC square plus the dimension BC square, and AB square is equals to, first, what is AC? Note that AC is this distance x1 and x2. So we are going to basically find the difference between x2 and x1. So this is going to give us x2 minus x1 all square plus the distance BC. So we are looking at the distance here, BC, and we can also see that it's the same thing from here, and the distance between y2 and y1. So this is going to give us y2 minus y1 all square. Recall, we are finding AB, not AB square. So AB squares give us this expression, but to find AB, we take the square root of both sides, and taking the square root of both sides, we are going to have AB equals to the square root of x2 minus x1 all square plus y2 minus y1 all square. So we are taking the square root of this. In general, this formula is used to find the distance between any given 2 points. Now let's take a look at illustrative examples. So if we have a point A given to be 2 and positive 5, and we also have a point B given to be minus 3 and positive 3. So we have to find the distance A between A and B. Alright, now we've already established this formula, so we go ahead and substitute them into that formula. First, before that, let's identify the point. This is going to be x1 and this is going to be y1. So minus 3 will give us x2 and positive 3 will give us y2. So we can say that the dimension AB, or the distance between AB, is equals to x2 here is minus 3 minus x1, which is positive 2 all square, plus y2 is positive 3 minus y1, which is positive 5, and this is all square, taking their square root, and AB will be equals to, if you compute this, minus 3 minus 2 will give us minus 5, so this will be minus 5 square, plus 3 minus 5 will give us minus 2 square, and you take their square roots. We have AB equals to, if you take the square root of minus 5, you are going to have positive 25. Basically, we are just saying that this is minus 5 times minus 5, and that will give us positive 25. And this will be minus 2 square, and if you take the square root of minus 2, the same thing, you're going to have positive 4. And when you sum this up, you are going to have the square root of 29. So first of all, you say 25 plus 4, which is 29, and take their square root. So therefore, we can say that the distance between the point A, B is equals to the square root of 29 units. Now you have to take note that when we are finding the distance, it could be in meters or in kilometers. It's always in a single unit. Unlike the area, we have to find this always giving us in a square unit. Alright, let's take a look at another illustrative example. So if we have a point C, and this is given to be positive 6 and minus 4, and another point D and D given to be 0 and positive 4. So we have to find the distance between C, D. Okay, now I want to make this clear. The first given point is where we always have our x1 and y1. So from this, we will say that x1 is equals to 6 and y1 is going to give us minus 4. So this is the first point, and x2 will give us 0 and y2 will be equals to positive 4. Now recall from the formula we established or we obtained, we said that finding the distance between two given points, we'll always have to take the square root of x2 minus x1 all square plus y2 minus y1 all square. So let's go ahead and substitute this value into this expression. So this will be the distance CD equals to the square root of x2 is 0 minus x1, which is 6 square, plus y2, which is 4, minus y1, which is minus 4 square, and this will be C, the distance CD equals to 0 minus 6 will remain minus 6 squared, plus 4 minus minus 4. Recall minus minus gave us positive, so this will be positive, and we can say that that will be 4 plus 4, which is 8 squared. So from here we can say that this will be equals to the square root of 6 squared will give us 36 minus 6 squared will give us 36 plus a squared, which will give us 64. So when you take the square root, and this is CD, when you sum this, you are going to have it to be the square root of 100, and the square root of 100 is 10. So we can say that therefore the distance between the point C and D is 10 units. Is equals to 10 units. Let's take another illustrative example before we bring this section to an end. So we have a point P given to be -8 and -6, and another point R given to be +1 and +9. So we have to find the distance between P and R. Alright, so from this formula we established, we can say that the distance between P and R is going to be equals to, take the square root. First of all, let's identify the point. Here is x1 and this is y1. Remember, the first point given is always the x1 and the y1, and the second point we will find our x2 and y2. So which is okay, y2. Now from here, x2 is 1, and this will be 1 minus -8, which is x1 all squared, plus, and y2 is 9 minus -6 all squares. We're about to take the square root, and here we are going to have PR equals to the square root of 1 minus -8 will give us +9, so this will be 9 squared, plus 9 minus -6 will give us 15, and this will be 15 squared. From here you can say that 9 squared is 81, plus 15 squared will give us 225. Okay, so this will be the distance PR. Then from here, if we compute this, we are going to have the square root of 306, and this can be written as 3√34. When you compute this, take the square root of 306, we are going to have 3√34 units as the distance between PR. You can also express this as a decimal point. In the next lesson, we are going to see how we can determine the type of a triangle when the vertex of the triangle is given. See you